Now, the next machine learning algorithm is artificial neural network. So basically, the idea of artificial neural network is borrowed from the human brain network. So just see here, the human brain is nothing but a collection of millions of neurons. So there are millions of neurons in human brain. So the how human brain works, the same principle is copied into the artificial neural network. So how the human brain works, just see here, if the human is moving forward and suddenly he looks that okay, some fire has occurred. So what he will do, what will happen inside the human brain? So whatever the information that will be sensed by the human eyes. So eyes, nose, they are basically the sensors of the human being. So the eyes will act as a sensor and it will sense the information about the fire. The fire has occurred, so that information will be flown to the human brain through the veins of his body. So what will happen once that information will be reached to the human brain? The human brain will process on it, and if after processing the result is beyond the threshold value, so it will instruct the human organs to perform some actions. So what kind of actions the human organs will perform? So the human will stop over there, suddenly stop over there, and it will start moving away from that fire. So this is how the human brain works. So the idea of artificial neural network is that can we design such a classifier, such a machine learning model that acts as a human brain. Now just see here, human learns by how the human learns. Suppose if we talk about a child, a little child who does not know about the alphabet A, alphabet B, alphabet C. So how does he comes to know about the alphabet A, alphabet B? So the teacher or his mother tries to give some examples to him. Okay, just see, this is an alphabet A, this is an alphabet B, and by giving some examples, the child is able to learn. So just see here, the humans are able to learn by the example. So this is how the idea is borrowed from that, and here we are just constructing a artificial neural network, and we are providing some examples, we are providing some training data set to that artificial neural network model, and that model itself able to learn from that input. And once it is learned, now it is ready to perform some testing, and based on some testing performance, we can say that okay, this model is that much percentage efficient. So similarly, if the child is now, suppose some examples, some questions are the teacher is teaching the students during the semester, all the semesters, and he gives some examples. He talks about some topics. He talks about some problems, the solution of the problems, and once now the students are learned enough and the course is completed, now that student model is ready to be tested. So what happens? The teacher takes the test. Now how much percentage the students are getting? So out of 100%, if the student is getting 90%, so overall if we are finding out the average percentage, so we can say that whatever the model we have built, how whatever the model that is learned, that is this much percentage efficient. Now just see here, since we are considering that the human brain has millions of neurons, so here the neural network, artificial neural network will also have set of neurons. So it will have input layer, so it will have middle layer, that is called the hidden layer, and the third layer is called the output layer. So basically the input layer and the output layer, there is a hidden layer, and it may be the case that it may have more than one hidden layers also. Now just see here, there are the n number of inputs we are being given input to this artificial neural network, and the hidden layers are responsible to process on it, and finally it produces the output. So output 1 and output 2 we are getting from this neural network. Just see here how this artificial neural network works. So if we talk about the simple neurons, just see here the third diagram, the lowest level diagram. This third diagram is the basically diagram for what? Diagram for a single neuron. So single neuron can be treated as, just see here, it will have a two parts. The first part is what? Summation, and the second part is what? The activation function. So what does the summation do? Summation finds out the what? The inputs will be multiplied by the corresponding weights here. Just see in the second diagram. So the edges which are connecting the input neurons with the hidden layer neurons. Similarly, the hidden layer neurons to the output neurons. The whatever the edges they are connecting, they are assigned some weights over here. These weights are very important. These weights are basically able to learn. These weights are being finally are being used to get the output for any unknown input. So these are very important. These weights are, the idea is artificial neural network is we have to find out the exact values of these weights. So initially what we do, initially we initialize these weights with some random values which are approximately near to zero. Then what we do, we perform learning. So how the learning are performed, just see here. The input is multiplied by their corresponding weight. Just see here, input x naught and put x1. So for the input node 1, now it is being passed to the header layer node 4, and also it is being passed to the node 5. So node 4 and node 5, it is passed through node 4 and node 5. So this input will be multiplied by their corresponding weight. So first multiplication will be x1, then w114. The second weight is W15. So X1 multiplied by W15. Similarly for the input X2 also. So X2 multiplied by W2, W24, and X2 multiplied by W25. So this is how we perform the summation over here. Just see in the third diagram, summation acts like this one. So summation of Xi, Wi, and we are also adding some bias also in order to make it perfect learning. So now this is what, after performing these operations, this value is being passed to the activation function. So activation function, that is f is written over here. So this f is, if what it does over here, so it basically applies a non-linearity in artificial neural network. So basically it normalizes the output in between 0 or 1 or -1 plus 1. If you are using Tansig activation function, so it normalizes the output in between -1 to +1. If you are using log sigmoid function, so it normalizes the output in between 0 and 1. So this is what. Now we will discuss about how it learns. Suppose we have initialized these weights some random values, and we are providing the input to this neural network, and we are just performing the summation operation, and then we are passing to the activation function, and some value we are getting over here. So what happens, since it is a supervised learning algorithm, supervised machine learning algorithm, so we are providing a set of input values as well as the output values. So what will happen here, so whatever the output we are getting after this output node, and then corresponding target output will be given, because for that particular input we already know the output, because the training data set will have the input as well as the output, and it will be provided to train the artificial neural network. So we know the actual output, whatever the output is coming over here, whatever the output is coming over here, that is the actual output, and the other output which is already, we know that the target output. So now the actual output which you are getting, and that is the target output. We find out the difference between, means we find out the error. So what we do here, we just try to minimize that error over there. So how this minimization is performed, so what we do, this error is being again being fed into this ANN model, and then again the weights are modified as accordingly, so that we gets the lower error, we gets the lower difference between the target output and the actual output, and this process is repeated until we get very lowest error, means the actual output approximately reaches to our target output. So this kind of learning is known as feed forward back propagation learning, because we are feed forwarding the input data set, and we are back forwarding what? We are back propagating what? The error, whatever the error is coming. So that is propagated to the neural network in order to minimize this. So we adjust the weights and biases in such a way so that the error should be minimized. So this is how the artificial neural network works. And next is self-organization map. So self-organization map is developed by Tuvo Kohonen in 1980s, provides a data visualization technique that is trained using unsupervised learning. So basically here we don't require any supervisor. While in the previous case, artificial neural network, it is a supervised learning, so we need supervisor. So supervisor means we have to provide some training data set which will already have some input as well as corresponding output. Why? But in this case of self-organization map, we don't need any supervisor, we don't need any kind of output, but we just provide a set of input to the classifier. Now, Zoom, it reduces the data dimension and displays similarity among the data. Just see here, we have a large amount of data set. So using that large amount of data set, the traditional statistical technique, they are not able to analyze those data set. So this is the curse of the higher dimensionality. So how? So can we reduce this higher dimensionality to lower dimensionality? Why? Because if we get anyhow, we get the lower dimensionality without affecting the importance of the data set. Important data set, if you are able to get the lower dimensional data set, so the analysis will be very easier, will become very easier. Now just see here how the self-organization map reduces the high dimensional data set into low dimensional and most of the cases into two dimensional data set without any external supervision. So self-organization map differs from the other artificial neural networks as they apply competitive learning as opposed to error correction learning such as backpropagation used in artificial neural network. So basically here self-organization is such a network in which each neuron is fighting for what? Is fighting for winning. Is fighting for to be winning nodes, so to be winning candidates. So that is why here competitive learning is performed. So every node is competing for what? To be winning, to get the desired output. Now just see here, the complex data set consisting of a massive amount of columns and the dimensions and demonstrate how the data set's dimensionality can be reduced. So instead of having a deal with the hundreds of rows and columns, so the data is processed into simplified map, that is the two-dimensional representation map, that is SOM map, self-organization map, which is easier to read and analyze. So in the following case, the dataset from the World Bank containing all 39 indicators of the human development, processed them into a self-organization map and then applied to a word map. So basically, we have a performance indicators for the human development dataset for approximately more than 200 countries, and for each basically in the form of table, and each row in the table corresponds to a country, and each row in the table having around 39 columns. Just here we have such a huge amount of data set. So just directly using this data set and analyzing this data set is not very much easy. It will be very difficult. So what is the better option? Can we map into like a Google map where we are where the different regions are colored with different colors. So similarly, based on these parameters of human development, we will color those regions which have approximately same performance indicators, which are indicators for the human development. Just see here, just see here in this diagram, we have this large amount of data set over here, and what we are doing, we are applying the self-organization map over here. So what it does, it colors the regions based on its similarity on the performance indicators. So now based on this performance indicators, now it is looking very easier to analyze the different regions of the words, and and these colors can also be ranked with the numbers. So which color will be ranked higher, and which color will be represented with a lower index value, and based on those index values we can compare the performance indicators of the countries over here. So this is how the self-organization map works. Now next is K means clustering. Now what is, first of all we will discuss what is clustering. So clustering is what? Clustering is basically unsupervised learning method. Just see here, classification is what? Classification is a supervised learning method. So we need a supervisor over there. So how the supervisor works over there? We provide the training data set in which it will have the input as well as the corresponding output. So the training data set will act as a supervisor in case of supervised learning. While in the case of clustering, we do not have such a supervisor. So we do not have any training data set available, but we have just input data set is available and no corresponding output is available. So based on its intrinsic features, the algorithm should be able to learn itself in order to classify the different groups. So basically, the cluster is what? The cluster refers to a small groups of the objects. So clustering is grouping those objects into the cluster. So clustering is dividing the data points into homogeneous classes are the clusters. So based on what? Based on some attributes, based on some features, and just finding out the similarity and dissimilarity between those features. So most of the time, the similarity and dissimilarity is being found out by by calculating the distance. Suppose now we have one feature which has n dimension, x1, x2, x3 dot xn. We have another feature, so that has also n dimensions. So y1, y2, y3, yn. Now we want to find out the similarity between these two features. So what we'll do, we will just find out the distance between these 2 points. How the distance will be calculated? If we talk about two coordinate systems, so we find out the distance under root x1 minus x2 whole square plus y1 minus y2 whole square. If we are talking about n dimensions, so how we can find out the distance? So d is equal to so basically it will be d is equal to under root x1 minus y1 whole square plus x2 minus y2 whole square plus x3 minus y3 whole square plus x4 minus y4 whole square dot xn is minus yn whole square. So just see here, we can find out the distance between two vectors having dimensions n. So if this distance is coming least, so we can say that the two data points are similar. If the distance comes larger, so we can say that these data points are very dissimilar to each other. So based on this principle, the K-means clustering works. Now K-means is basically it was invented by the McQueen in 1967. Is the one of the simplest unsupervised learning algorithm that solve the well-known clustering problems. Now just see, the clustering is what? Basically clustering is to divide the data points into homogeneous classes are the clusters. So basically we can say that if we are dividing a data set into two clusters, it means so the data point of each clusters are very much similar, and the data points of two different clusters, they are dissimilar. That is why they are being put into different clusters, and the data points of the same clusters are being put in the same clusters. So we can say that they are very much similar to each other. So the points in the same group are as similar as possible. So and points on the different group, they are as dissimilar as much possible. Just see here, in the first rectangle we have a set of data points. Now we are applying some K-means clustering over here. Now first time what happens, based on if you are talking about K-means clustering, so here we are finding out the K centroids. Means centroids. So first of all, suppose we have this set of data points. Now suppose we want to group it into two different classes. So first we will randomly select two centroids, two means. So value of K will be 2 here over here. So now we randomly select 2 points, and what we do, we find out the distance of each point with these 2 points. So the point which has a least distance with any centroid that comes into that group. So just see here in the second diagram, it forms a two cluster over here, and data points which are very near to a particular centroid, they come into same cluster. So the first centroid comes in the first comes around center of the first cluster, and the second centroid comes around the center of the second cluster. Now, after forming these two clusters, now we again find out that means we again find out the centroids. So this centroid will usually it will get changed. So how we will find out centroids? Suppose we have 5 points. One point is x1 y1, and the x1 y1 x1 x2 x3 x4 xn. Second point is y1 y2 y3 yn. Third point is z1 z2 z3 zn, and next point is p1 p2 ppn. So how we find out the centroid? So x1 plus y1 plus z1 plus p1 divided by 4, comma, where x2 plus y2 plus z2 plus p2 divided by 4, so on. So this is how we again calculate the centroids. Now again we find out the distance between all the points between these two centroids, and the points which are coming closer, they are forming this, they are introduced, they are added to the same cluster. So again just see here the cluster to these two clusters, the size of these two clusters are changed. So again once we are able to form these two clusters, we again calculate the centroid. Again we are getting the same different kinds of clusters. This is how finally this process is repeated until the size of each cluster does not have any effect. So this is how, and finally we can say that this is about the final clusters which has been obtained using the k-means clustering over here. Now clustering helps marketers improve their customers base and work on the target areas. So clustering helps in identification of the groups of houses based on their values, type, and geographical locations. So for example, suppose a pizza chain wants to a company which wants to open a delivery centers across the city. So what do they think would be possible challenges? What are the basically possible challenges if we want to open a delivery center for the pizza? So the first challenge is they need to analyze the areas from where the pizza is being ordered frequently. So initially what they will do, they will assign those centers at the random centers initially. And just see, second point, they need to understand as how many pizza stores has to be open to cover delivery in that area. So and then they need to figure out the locations for the pizza stores within all these areas in order to keep the distance between the store and the delivery points minimum. So just see here the k-means clustering will be used, and we will perform the k-means clustering operations in order to decide the delivery centers and the pizza centers. Okay. Now the next is the hierarchical clustering. So this is another unsupervised learning clustering method. So it involves creating the clusters that have a predetermined ordering from the top to bottom. So for example, if we talk about the organization of the files and folders on the hard disk, just see here they are organized in a hierarchical format. Just see here, it will if we start from the suppose if you are searching out a particular folder inside the D directory, so D directory will be root folder. So root directory. Now inside D, we just see here we come into the local the next subdirectory. Then we inside that we go to the next subdirectory or next subfolder. Then we go inside that the next subdirectory. So just see here, so all the files and directories, they are basically follow a hierarchical structure. They start from the root. They have several branches over there. Now, so this kind of examples, this kind of methods basically can be used to apply the hierarchical clustering. So basically, hierarchical clustering are up to the two types. One is the divisive approach, and another one is the agglomerative approach. Just see here in this diagram. So divisive approach is what? We follow the top-down approach. We start from the single root, and we group the data set into different classes into different groups using the different hierarchy, different branches. Again, the further it is divided into the another groups. So this is how this top-down clustering works. A divisive approach works here. Now, in divisive or top-down clustering method, we assign all the observations to a single cluster. Just see here, for all the data set, we have how many data sets are there? One, P, Q, R, S, T. So all data sets are assigned a single cluster. So initially we start from the single cluster. Then the partition the cluster into two least similar cluster. So now it is being partitioned into two clusters. The first cluster has P and Q, and the second cluster has R, S, T. Now this process is repeated until we get all the clusters having the single element. Now see here, next time this PQ is clustered into two clusters, into two subclusters. One has P and another has Q attribute here element. Now this RST, it is grouped into two different clusters. One has R and another has S and T. And this again group into two subclusters, and one has S, another has T. So basically, we start from the top and we move up to the bottom. This approach is known as divisive hierarchical clustering approach. That is the top-down approach. If the process is reversed, like we start from the bottom level and we move up to the top level. So what we do here, so individual element is treated as a single cluster initially in case of agglomerative clustering. So just see here, P, Q, R, S, T, all these are treated as a single, as an individual cluster. So how many clusters are there? The 5 clusters are there. And we have to move upward, and we have to move upward in such a way, finally we get only a single largest cluster. So just see here, how we'll do it? By just finding out, by evaluating the distance, by evaluating the distance between the data points. Just see here, P and Q, they are very near to each other. If we talk about alphabetically, so P and Q are very near to each other, so they will be combined into one cluster. So P and Q will come into single cluster. Now the S and T, they are also very near to each other, so they are combined and they are come into the single cluster, which will have S and T. Now just see here, ST, the centroid of ST and R, they are very near to each other, so they are coming into single cluster. Now just see here, PQ and RST, the center of both these two clusters, they are combining into, and what finally we get, the final cluster has all the elements over here. So this is how the agglomerative clustering works in hierarchical clustering. Now just see here, in agglomerative or at the bottom of clustering method, we assign each observation to its own cluster, then compute the similarity. Similarity, how we calculate the similarity? By calculating the distance between each of the clusters and join the two most similar cluster, means least distances. So finally, repeat this until there is only one single cluster left. Now see how we can measure the distance. So basically there are 3 different methods to measure the distance in between two clusters in order to merge them. So if we go to calculate the distance between two clusters, and then only we are able to merge them, we are able to decide to merge them. Just see here, the first approach is single linkage. So how we calculate the distance between two clusters? In case of single linkage, the data points which are very near to the border of the clusters, they are considered to calculate the distance. Just see here, the nearest point means in the first cluster, just see here, this point is very near to the second cluster. Similarly, in the second cluster, this point is very near to the first cluster. So we will select the nearest point of a cluster which is nearest to the next other cluster, and we just find out the distance between these two data points. If this distance is coming very less, it means they in comparison to other distances, so it means they have to combine. So these two clusters have to be combined. Now the second approach is to find out the distance by using the complete linkage. In complete linkage, we chooses the 2 points in two different clusters which are farthest to each other. We just find out the 2 points and the two different clusters which are farthest to each other as much as possible. Just see here. This is the point which is very far away from this cluster. Similarly, this is the point in the second cluster which is far away from this cluster. So that is why now we just find out the distance between these 2 points. If this distance comes where it comes less than other distances, so then these two clusters may be grouped in hierarchical clustering. Now the third is finding out the distance using the average linkage. So average linkage, what we do, we calculate the distance between each and every points over here, in every pair of points over here. So now all those distances are the value of those distances are averaged over here by dividing the total number of elements over here. Now once this distance is find out and this distance comes less than other distances, so now we can combine these two clusters into a single cluster. So this is how the measurement of the distance in hierarchical clustering performed, and then based on the distance measurement we are combining the or we are combining or we are dividing a cluster into two different clusters, or the two clusters we are combining the two clusters into a single cluster. Now just see here, this is all about the clustering and classification and machine learning algorithms. So with the exponential growth of artificial intelligence, machine learning is becoming one of the most sought after field. So as the name suggests, machine learning is the ability to make machine learns through the data by using various machine learning algorithms. The evolution of machine learning has changed the entire 21st century. So it is starting to redefine the way we live, and it's time to be understood what it is and why it matters. So with the demand for more complex computations, we cannot rely on simplistic algorithms. Instead, we must utilize algorithms with higher computational capabilities, and such algorithms are advanced machine learning algorithms. Just see here. So we don't have to rely on the traditional techniques like statistical techniques, which are being able to handle very small amount of data set, which are not very much efficient. Since nowadays we have the availability of the data set is in large amount, and we need the analysis in order to improve the decision making system by the organization, in order to improve the profit of the organization, in order to improve the various parameter indexes. So we need the such an algorithms which may work on the complex kind of data, large amount of data set. In that case, the advanced machine learning algorithms comes into picture. So that is why we need machine learning algorithms. So these are the references. We can read out the books for the pattern recognition and image analysis also, and then the cognition analysis, psychology also. Thank you very much.